Today, we will continue our discussion about geometric sequences. Now, we're going to look something more specific, which is called an explicit formula. On our previous lesson, we saw what a geometric sequence was, and we talked a little bit about recursive formula. But today, we're going to talk about an explicit formula. So, know that the main idea for today is that you can find any term in the sequence using the explicit formula. The recursive formula had a limitation, which you needed to know the previous term to find the next one. But here with the explicit formula, you don't really need to know what's the term that came before. All you need to know is just some specific points, which we will discuss on our next slide. So know that today, the explicit formula, you can use the explicit formula to find any term in the sequence. So let's get started. Now here, let's talk about here for a little bit. Before we start talking about the formula itself, I want to talk about what is it that is made out of. Well, here, every geometric sequence can be defined using this formula. So any sequence that is geometric, we can find any term in the sequence using this formula. But now, what is all these variables here? Well, we have talked about some of them already. An, we talked about that an is the end term. A1, we talk about that A1 was the first term. Now here's a new variable here. N is the term number. And this term number, it's basically the term that you're looking at. You want to find the 20th term, N is going to hold the value of 20. You want to find the 50th term, then N is going to hold the value of 50. So N is, you can think about it as your target. What is it that you're looking for? And the common ratio, we talked about it, which is the number that you keep multiplying it by, but we're going to use the letter R. So again, An is the first term, A1 is the first term, N you can think about as your target, which is the term number, and R is the common ratio, or the number that you keep multiplying it by. Once you know those four items, then you can use the explicit formula to find the value for the term. So let's get some examples, because I feel like this kind of idea is better represented once we do some examples. Let me bring the formula down here. So here we're going to have some examples where we have a formula and we got the variables that we're looking for. So now let's talk about example 1 real quick here. Now, if you look at the direction, it says, well, we need to find the explicit formula for the following geometric sequence. So we need to come up with the formula for this sequence. Now again, if you want to find the formula, you need to know these four items. So let's go one by one. An is basically the end term, but in this case, if they just want the formula, so An stays as An. Now the first term, An is equals to An. Now the first term, well, we're going to look at our formula here. What was the first term in that sequence? Here the first term is 3. So that says that An has a value of 3. So we're done with the second. Now, N is a term number. When they're just asking you for the formula itself, then we're just gonna leave N alone. So N is gonna be N because we don't have a target yet. They're just asking us for the formula. So we're gonna leave N as N. And now we need to find out the common ratio. So what is the common ratio? The common ratio, we're gonna look at our sequence. And what is the number that you keep multiplying it by to get to the next number? Well, it seems like you need to multiply it by 3. So that says that the common ratio is just 3. Once you have this 4 piece of information, you plug it into the formula and you have the formula that you were looking for. So an stands for an, stays as an. A1, we found it to be 3. So it's going to be 3 times r, where r, we found it to be 3. So it's 3 times 3. And in the exponent, we have n minus 1. But here we know that n is equals to n. So we got n minus 1. So here's the explicit formula that we were looking for. Again, all we're doing, we're looking for this 4 piece of info, and we plug it into the formula. Let's look at example 2 right now. Let's put this checklist on the side. I don't think we need it anymore. Example 3, let's talk about it at the end. Again, all we need to know is what is an, what is a1, what is r, and what is n. So let's see. You got those 4 pieces of information, you plug it into your formula, then you have your explicit formula. That's pretty much it. So let's see. an basically is going to stay as an, just like the previous example. A1 is the first term, which we look here. The first term is just 5. R stands for the common ratio, which is the number that we needed to multiply to get to the next term. So it seems here that in order for us to get to the next term, all we really need to do is just multiply by 2. So that means that R is going to hold a value of 2, and N is going to stand for N. Again, you got those 4 pieces of information, you got a formula, just plug it in. AN, it's equal to AN, so that stays. A1, we found it to be 5, so just plug it into the formula, times R. But what is R here? R is 2, so plug in the 2, N minus 1, we know that N is equals to N, so that stays as N minus 1. So now let's look at the last example here again. Here, third example, all we need to know is just those 4 items, which were AN, A1, R, and N. So let's see, AN always stays as AN. A1 is the first term, which here we can see that it's 100. R is the common ratio. So this is a little bit tricky because notice, how are we getting to the next number? It seems like in order for us to get to the next number, we are dividing by 2. Because 100 divided by 2, that's 50. 50 divided by 2, that's 25. But we cannot really put division when it comes to R. So there has to be a way for us to represent division. And now, one thing in mathematics is that to divide is the same as to multiply by a fraction. So to divide by 2, we multiply by 1/2. They're going to give you the same result. If you divide something by 2, that's going to give you the same result as if you would have just multiplied by 1/2. So with that said, R is going to be 1/2 because that's the number that we needed to multiply by in order to get to the next number. We saw that we needed to divide it by 2, but we cannot put division in R. So we're going to leave that as multiplication of 1/2. And N stands for N. We don't have a target yet. They're just asking us to come up with the formula. Notice that N is not always going to be N. But here, they're just asking us to come up with the formula. They haven't asking us to find any term. So right now, N is going to stay as N. We have those four terms, or four items, I'm sorry. Then we just plug it in and we're done. So an is equal to a1, which we found to be 100, times r, which we found to be 1/2, exponent n minus 1. And this is the explicit formula for this geometric sequence. So now, here's your entrance ticket. Find the explicit formula for the following geometric sequence.